opposite angle by r by sine of opposite angle. It's not for 3. It's the same for any number of tensions, right? And and this is called the angle of friction. That is, the friction is minimum when the angle between the force and the body is tan inverse of nu. That is static friction, right? And then let's see questions. And again, there's again one more wedge constraint with friction. So for writing equations, all you do is identify where the forces are acting, where the friction is acting, and the direction of friction, and that's all. If you know this and write the equations accordingly, then you can solve the question. Like in this case, suppose the force is acting towards right, so the friction between m1 and the ground will be towards the left. So if we take f as positive, f1 would be negative, right? And let's say in between m1 and m2, m1 is moving this way, so there is some friction acting between m1 and m2. So m2 would be pulled in the same direction as m1, so the friction f2 would be acting towards right. So f2 would have the same sign as f because in the same direction, and f1 would have in the opposite direction. So yeah, this is all simple logic. This is all you need to remember to solve the questions. I'll show you how to solve every single question from this chapter by remembering only these. So let's go to the question. So yeah, the first question, it's like this string wedge block constraint question. It says for system shown, what's the tension in the string, right? So there's only one string. So the tension throughout the string, despite the number of pulleys, would be same, right? So what do you do now? You need to draw the free body diagram. So let's assume the tension in this string to be T. So who would tell me the free body diagram for the mass M, which is on the ground? What are the forces acting on M?
mg.
I want the force and the direction.
Okay, mg down the.
Okay.
And tension along the string.
Okay, this side.
Yeah.
And what else?
And if we talk about the wedge, the mg sine theta.
Okay, fine. In this case, if mg is acting, there's something else also acting, right? If mg is acting,
normal.
So if this is the net motion of this mass is 0 with respect to y-axis. So if something is acting on the y-axis downwards, something has to act on in positive y-axis, right? So there's normal acting here. There's mg acting downwards, and some tension is acting this side. Yeah, that's correct. So what about the mass? Sorry, the free body diagram of this mass. Just tell me the forces and directions.
mg.
Mg where?
Along that wedge.
Okay. Mg
then
usually acts perpendicular to the ground, right? So what do you do
that? Yeah. Then it will break into two components: mg cos theta and mg sin theta.
Oh, what is the component parallel to the wedge?
Mg sin theta.
All right,
and that perpendicular, it will be mg cos theta.
All right, and what else?
And tension along the string.
Okay.
And normal from the wedge.
All right. So yeah, now you know normal is opposite to perpendicular to the wedge, right?
Yeah.
So yeah, now we know the forces and you know the directions as well. So let's try to write the equation. So yeah, these are the forces and these are the things. So yeah, let's see the equation, right? How would the equation be? Let's assume that this mass is falling downwards and this is coming towards the left. So how would the equation be? And yeah, before that, you can assume anything, right? Usually, you can assume it to the mass. You can assume that the mass is going this way also. The only difference is everything would turn out to be negative. So yeah, let's assume that the mass is going this way. So what will the equation be?
Mg sin theta will be equal to the tension.
It is equal to tension when it is stationary, right?
Okay, yeah, yeah. Since it's moving downwards with the acceleration a, mg sine theta minus tension would be ma.
All right. So acceleration of this thing, right?
Yeah.
Okay. Mg sin theta minus t equal to ma. Then what about this block?
Um, t is equal to
T equal to what?
ma.
So you're saying the acceleration for both the wedges are equal.
Yeah, I think so.
Yeah, they're equal. So you got the first equation for the first one, and the second one is t equal to ma. Now, what they ask in the question? They just ask the tension in the string, right? So that's all. You know the equations. Substitute equation two and equation one, and you get the answer. I think it's option C. Yeah. So you guys clear how to do this?
Yeah.
Uh, I can't see everybody. Everybody else, did you just tell me yes or no? All right, I'll tell the steps again. Uh, find the forces, find the direction, and for writing equations, if you're writing equation for mg sine theta, you need to use the forces which are in the same axis. So in this axis, mg sine theta, there is tension. So you need to write the equation in this direction, and over here, only tension was here and acceleration was in this one. So you write the equation, you substitute, you'll get two or three equations, substitute, and get the answer. So that was pretty simple. Let's get to the next question. It says the minimum force required to move a body up an inclined plane is 3 times the force required to prevent it from sliding down the plane. If the coefficient of friction between the plane and the body is 1 by 2 root 3, then the angle of inclined planes. So yeah, just tell me your approach first. How do you approach this? Guys, anybody, any ideas? Hey, I guess there. Guys, come on. Just tell me. It maybe even if it's wrong, it's okay. How do you approach this question?
So the minimum force, it says the minimum force required to move it through the inclined planes is 3 times to the minimum force required to prevent it from sliding. So it will be like in opposite direction.
Okay. Yeah,
Uh,
that's correct. So
mm,
I told you what to do in the previous questions, right? How
yeah.
to. So yeah, what do we do? What's the first step?
Mm, make the free body diagram.
Exactly. You draw the free body diagram, right? So
Yeah.
okay, free body diagram. It's a wedge and a block.
Yeah.
Uh,
So mg sine.
yeah, mg sin theta is parallel to the plane, right?
Yeah. Minimum force.
So what they ask, the minimum force required to move a body up the inclined plane.
Uh, is 3 times the minimum force. So
Here
mg
there's
sine
friction,
theta
right?
will be
There's
equal
friction,
to,
right?
yeah, that's friction.
In this free body diagram, you need to the friction of the direction of friction in the first case and second case. Is it the same or the opposite? What do you think?
In the first case, it will be opposite.
Okay, in the first case, we're moving the body upwards, right? So,
Yeah,
what is the direction of friction? Is it upwards or downwards? Okay.
upwards.
Why do you think it's upwards? What does friction?
Because it opposes the
Yeah, it
it
opposes
opposes
the
the direction
net
of
force,
force.
right?
Yeah,
So, if
yeah,
you're moving the body upwards, then how would the direction of friction be? It'll be the opposite, right?
yeah.
So, the direction of friction will
Oh,
be downwards. You
yeah,
get it?
yeah, yeah. Yeah, I
So,
got it.
you know the direction of acceleration. You know the direction of friction. Now what? Now
Mm,
you need to find the magnitude of the forces, right?
yeah,
So, what is the force of friction? What is the formula?
friction. Mu,
U
um,
into
mu into mu
normal.
into normal. Yeah,
Yeah, so near to normal. Uh, so as you said, the block is in the wedge. The force parallel to the wedge is mg sine theta. So what is the normal?
Normal mg cos theta.
Yeah. So you know the normal. So what is the direction of so what is the direction magnitude of friction?
Direction of friction would be, since the wedge is moving downwards, the block is moving downwards, the direction of friction will be upwards, and
Mhm.
it's given that it's three
They
the
gave new, right? They gave new,
yeah,
that is 1 by
yeah,
2 root. And
yeah.
normal is,
Huh?
what is the normal force?
Normal force, it's mg cos theta.
Yeah. So you know the value of friction, you know the direction of friction. So now let's try to write the equation for both the cases. All right.
Yeah.
So in the first case, what they say, the body is moving, they're pushing it, right? So the body is moving upwards. So how do you write the equation? The direction of acceleration is upwards. The direction of friction is downwards. And what else? What else force is there?
Mg sin theta.
Which direction?
Downwards.
Downwards. So now tell me the equation. You know the directions and magnitudes.
Okay. Mg sin. Okay. It will be ma
Assume that
is
the
equal.
force you're using to move it upward is F. Now tell me the equation.
Okay. Mg sin theta minus mg sin theta plus friction will be
Equal to
ma.
exactly. Yeah. So you got it right.
Yeah.
MA, that's F1. Let's assume the first case is MA F1. What is ME sine theta downwards plus the friction downwards, that is nu cos theta. Correct.
Yeah.
You got it.
Yeah.
So now tell me the equation for the second one. Second one, it says uh, it is to prevent it from sliding downwards. So now tell me the direction and magnitude of the forces. Which direction does mg sine theta act? Which direction does friction act? And which direction?
Okay. Mg sin theta will act downwards only,
All
and
right.
since it is to prevent it from going downwards, friction will act upwards.
And the opposite, right?
Yeah.
So let's assume the force is F2. Now tell me the equation for F2. You're the wedge is sliding, you're holding
Hmm.
it, you know the direction of mg sine theta, you know the direction of friction.
Okay. It
Now tell me the, yeah,
mg sin theta minus friction would be ma.
yeah, it's F2, right?
Yeah.
Uh, so you know the equation of, you know the value of F1 and you know the value of F2.
F2.
Wait. Oh, they said minimum, okay, it's not moving upwards, sorry. First one is moving upwards. Second one, they said minimum force to prevent it from sliding. It's not moving, right? So, uh, what is the minimum force to prevent it from sliding? Mg sine theta, and then it's mg sine theta, right?
Yeah.
It's not moving, so it's only mg sine theta. Do you get it? So, see, if it's moving, friction is acting. In the second case,
Yeah.
it says minimum force required to prevent it from sliding down. It's not moving, so there's no friction acting there.
Yeah.
So the only force acting there is mg sine theta.
Mg
You get
sin
it?
theta.
So that's F2. They said the relation between F1 is 3 times of F2.
Hmm.
So you get mg sine theta plus friction equal to 3 times of
Mg
uh,
sin theta.
mg sine theta. You got, this is how you do this. And if you
Yes.
substitute the value of mg sine theta, I mean mg sine theta is cos theta and nu, you get uh, no, my stylus is my laptop is not supporting today. Yeah. So okay, I have those steps here. All right, fine. See, did you get this?
Yeah.
Wait. This is some error. Now you try to you know the equations, right? So try to work the question. Just tell me the answer.
Yeah.
What about Bhumika, Mukesh? Oh, yeah, Bhumika.
It's 30 degree.
How do you get this?
Mg sin theta plus friction will give is equal to m 3 mg sin theta, right?
Yes.
Then friction is mu mg cos theta, and that by subtracting 3 mg mg sin theta from 3 mg sin theta, you will get 2 mg sin theta there. So
Uh,
mg sin theta, mg sin theta will cancel out, and
mhm.
then mu will be equal to 2 tan theta.
Mu equal to 2 tan theta. Okay. If mu is 2 tan theta,
Sorry.
wait, if mu is 2 tan theta, then yeah, substitute mu. That's all.
Yeah,
So
the
nu,
value of mu is given.
it was 1 by 2 root 3, right?
Yeah,
So you get tan theta equal to 1 by root 3.
yeah,
Yeah, so theta equal 30. That's correct. Did you get this? How to do the question?
yeah, I got it.
So yeah, just to recap, uh, find the forces, find the magnitude, find the direction, and simply write the equations. That's all.
Yeah,
So let's move to this question. It says it's a block M1 which is 1 kg and M is 6 kg. It said this one is smooth. So surface between the ground and capital M, there's no friction, and there is some friction between small m and m capital M, that is 0.3. And it said this one is given a velocity of 2 meter per second square, meter per second. Sorry. Then find the acceleration of q relative to p. So this is a pretty tricky question. So yeah, what's your approach? What do you think we should start off with?
make free body diagrams of.
Exactly. So yeah, try to make the first. Let's make the fluid diagram for capital M, right?
Yeah,
So for capital M, there is no friction between the surface and capital M. There is only some friction between P and Q.
small m and yeah,
Yeah. So the motion of M is purely responsible due to the friction between P and Q, right?
yeah,
So if we consider the friction acts in this towards the right, right?
yeah,
So if we consider the friction of F equal to F equal to ma, you get acceleration of m, right?
q, yeah,
So let's assume other steps. So F equal to nu mg, you know that is uh, nu 0.3, and normal force of this thing is mg. So you know the value of F, which is equal to capital M into acceleration of capital M, right?
yeah,
Did you get it?
yeah, I got it.
So you let's assume the acceleration of q is nu mg by m. So now coming back to the smaller mass, how do you write the equation, like the friction of this thing?
um,
It's the same, right? Because
Yeah, their friction will be in the opposite direction to
yeah,
the
friction in
left.
the opposite direction. And
Yeah.
what will be the magnitude? The friction force is same. So what's the acceleration? Sorry.
Um,
See, the friction force is same, right? Only the
yeah.
direction is changing, and the force uh, the force is nu mg for both of them. For capital M,
Hmm.
it's towards the right. For small m, it's towards the left. And what we need to find is the relative acceleration of P and Q. To find the relative acceleration, we need to find the acceleration individually, right? So,
Yeah.
for since the friction is same, acceleration is simply F divided by capital M for Q, and F divided by small m for P.
P.
Did you get it?
Yeah.
So you know the values of acceleration, and the sign it's negative for P and positive for Q.
Positive for Q.
So now they asked us to find the relative acceleration, right? So all we need to find is find the values of these things and then subtract them. So how do you think we can find the values? We need one more equation, right?
Yeah.
Why? How do you think we can do that? Do we need one more equation?
Hmm.
Think. I'm just trying to confuse you. They asked us to find the acceleration of q related to p. That means in mathematically it is aq minus ap, right?
Hmm.
So yeah, we know the value of
Yeah. We have the equations.
aq and ap, right?
Yeah.
So what is aq minus ap? Uh, it's just simple math, right? It is
Yeah.
this thing minus this thing.
Hmm.
So you know the value of small m, that is 1 kg. You know the value of
1 kg
6 kg.
and
You know
capital.
nu, you know g. So you substitute, you subtract, you get the
Yeah.
answer. Got it.
Yeah.
But in the question, they just give d equal to something something. So they just do that to confuse you. So yeah, so if you have to save time, you just blindly draw the FBD. Uh, I mean, find the forces and directions, write the
Yeah.
equations, solve the question. Did you get it?
Yeah. Got it.
Alright. So yeah, let's look at this question. 10 kg stone suspended with a rope of breaking strength of some 30. The minimum time in which the stone can be raised to a height of 10 meters, starting from rest. Okay, so this is a diagram.
Hmm.
Uh, it says the maximum tension in the string is 30
Is
Newton.
that?
30
Yeah.
Newton can be applied to the string before it breaks, right? Uh, and they ask minimum time in which, okay, to find minimum time, and given the distance, all you need is acceleration, right?
Yeah.
So, okay, now tell me this. Suppose you're in a lift and you have some box hanging in a string. So at rest the tension is T, right? So when the
Yeah.
lift goes upwards, would the tension be greater than T or less than T? You can draw the free body diagram.
Wait.
Come on, it's, uh, there are two scenarios. First case is when the lift is going upwards, so
Yeah.
that's T1, and the lift is going downwards, that's T2. So will T1 be greater than T or less than T? Will T2 be greater than T or less than T?
Um.
See, it's going upwards. The
Uh,
tension is pulling, like,
tension is upwards, and there will be mg downwards,
yeah, there'll be mg
and
downwards.
acceleration is upwards. So the
Yes.
equation will be t minus mg is equal to ma, right?
Yeah. So,
And when it's going downwards, the lift is going downwards.
mhm.
It will be T mg minus T is equal to ma.
Yeah, so the tension is greater when it's going upwards, right?
Yeah,
And it's lesser when it goes downwards.
going downward. Yeah,
So yeah, we'll be using the same thing in here. It says that stone is suspended. Yeah, the minimum time in which the stone can be raised. So the thing is raised uh, in the rope. So there's some acceleration we're giving upwards, right?
yeah,
So I think you have the equation already. What was the equation when it goes upwards?
yeah. T minus mg is equal to 10a.
Exactly. So they said for minimum time the acceleration should be maximum, right?
Yeah,
So the acceleration is maximum, the tension is maximum, and the maximum tension that can be given is 30,
is
right?
30.
So
Yeah,
you know T, you know M, you know G, and you can
yeah,
find A, right?
yeah.
So yeah, now try to just tell me the value of A.
Can you tell me the tension again?
It's 30.
30. 7.
7.
Sorry,
So
sorry, sorry. Let me give
this,
it again.
I think it'll be around 20, I guess.
Yeah,
Yeah, it's 20, right? I mean, just
yeah.
substitute T is equal to 30, and
I did some silly mistake.
yeah, it happens. Just try to avoid that. So
Yeah.
you found the acceleration at which the stone can be raised in the minimum time. But they didn't ask the acceleration. What they asked? They asked what is the time in which it can be raised through 10 meters. So yeah, you have the acceleration now. You have the distance. You need to find the time. So what do you use? Come on.
S is equal to ut. Sorry, sorry.
Yeah, come on, go on.
Um,
X is equal to UD plus half a d square, right?
yeah,
Yeah,
yeah.
and they gave that U is 0 because it is starting from rest. So yeah,
U will be 0.
yeah. Now just put the formula, get the answer. I think substitute it. The answer will be 1 second. So do you get this? Is
Okay.
this clear?
What was the time? 1 second.
They ask the time in which it
Okay,
can.
time we have to tell.
Yeah. So you found the acceleration through which it's taken upwards,
Oh,
and they
10.
give 7 meters.
1 second, 1 second.
Yeah. Yeah. 1 second. Cool. So did you get this?
Yeah,
Again, draw the FPD, write the equations.
and solve.
So this is a pretty nice question. It says the figure the ball is released. It says MA is released, and the block should just leave contact with the ground, and minimum mass of A should be. A lot of people get stuck up in this question because they just don't know the condition. They just don't know what does this mean. Block B just leaves contact with the ground. So just remember this when they say it just leaves contact with the ground means in terms of free body diagram, normal force equal to 0. Just when they release it, this moves downwards, so this somewhat moves upwards. So when it just leaves contact with the ground, that means the normal force between them becomes 0. So if you put the condition, uh, then you can solve the question. So again, yeah. Now tell me what are the forces acting in the body. Let's start with small m. What are the forces?
Tension.
Tension upwards and
Yeah, mg downwards.
the downwards. Cool. So and then there's the spring here, right?
Spring. Yeah, spring.
So what is the free body diagram for m?
Um,
And it just leaves contact with the ground.
the normal will be 0.
Yes.
There will be mg downwards.
and
and tension upwards and
okay, okay.
spring
Before
for
fine, let me make this clear. When there's a spring here, this
yeah.
tension would have no effect in this mass.
Okay.
Right. So there is spring force. So what happens is when you release this mass m, uh, this spring elongates. Right. It's not
Yeah.
constant. It does not elongate constantly. It just elongates, and after a particular elongation, m starts rising upwards. All right.
Yeah.
So uh, initially the elongation is zero. It elongates up to some x naught value, and at that x naught, uh, this m capital M just leaves the ground. So when we write the free body diagram, uh, you need to consider the elongation at which it just leaves the ground. Let's assume the elongation at which it leaves the ground is x naught. So what is the force of a spring when elongation is
Force
x?
of spring will be kx naught
Yeah, kx. Right.
downwards.
So
Downwards.
yeah, now tell me the free body diagram for capital M.
It will be mg downwards,
And
kx naught downwards, and acceleration
wait, why
upwards.
is kx not downwards?
Because the spring will elongate.
One second, one second. I didn't get you. See, if the spring is elongating, uh,
Yeah.
what the spring does is the spring basically it pulls both the ends. So the spring pulls this rope. It also pulls this mass. The property of a spring, it tries to maintain its natural state, right?
Yeah.
So uh, it pulls both the sides equally. So uh, it tries to pulls m upwards, right, through so that it comes to its natural state,
Okay.
right? So what will the force of the spring? It will be downwards or upwards.
It will be upwards.
Okay, I don't think you got it still. We assume that the elongation at which it just leaves the ground is x naught.
Yeah.
So at x naught, uh, the spring pulls the mass such that it leaves the ground. So that's the reason the force of spring is upwards. Uh,
Okay.
this is for the mass m. Okay. Uh, so yeah, now did you get the equation for capital M?
Yeah.
It's kx naught upwards and
Kx naught upwards. A
mg
upwards.
upwards.
Yeah. Mg downwards. It will be kx naught minus mg is equal to ma.
Ma is upwards, right?
Yeah. Ma is upwards.
Yeah, correct. So you know the equations of both. Now let's what they asked. They asked the minimum mass of A, and the
Yeah.
options are in terms of M. So what do we have till now? We have this one. We have uh, this equation, right?
Yeah.
And fine. So yeah, this all the now I'll tell you what to do. So now we have X, right? So how do you think we can solve X?
Mm,
They asked M in terms of capital M. All the
capital
equations
M.
are capital M. Now you have the equation of first one, the equation of the second mass, and you also have X, right?
Yeah.
So how do you think it's all X? Okay. Uh, so I just want to tell you that the elongation of the spring is never uniform, right?
Yeah.
The elongation of the spring is it elongates a little bit initially, and then it elongates more. It totally depends on the masses. So
Yeah.
it's not about elongation; it's about anything in physics, and it is not constant. And when you need to find the total of something, all you do what you do is integration. It's the same with
Okay.
velocity also. So when the velocity is not constant, it's a variable of time, and then they ask you what is the total distance traveled. So you need to integrate it. Did you get it?
Yeah.
So in this case, the spring is the elongation of spring is not constant; it is variable. And what you need to find the total elongation. You know the total elongation. So what do? You indicate it.
Oh,
So this is the equation. You have the equation, right?
yeah.
Uh, okay, I want you to answer. How do you think we can do this?
Oh. We have VDV. DX co we can send that side.
Okay. See, you have mg, you have
Yeah.
kx. I told you already that uh, the spring pulls in both the directions, right? If it is pulling
Yeah.
in this direction, it also pulls the string downwards,
Yeah.
right? So the tension in this spring is nothing but kx. You get it?
Yeah.
Uh, so yeah, you got this, and that's what they wrote here, right? Uh, they took this m this side. Now they have acceleration equal to mg minus kx.
It's
So
KX.
what we have in hand, we have this equation. We have the final elongation at which it leaves the ground. We have x naught.
Yeah.
So we need to eliminate x somehow, right? And we also don't know anything about acceleration. So what they did here is they wrote acceleration in this.
As VDV. Yeah.
Acceleration is nothing but dv by dx, right?
Yeah.
And how did they get this? Sorry, dx by dt. Come on, here. Acceleration is dv by dt, right?
Yeah. DV by DT.
dv by dt is acceleration. And
Yeah.
what is v?
DX by DT.
Exactly. So wait, I'll try to write. I'm sorry, my graphic tablet is not working today. That's what I've
Huh.
written. So yeah, uh, you have acceleration equal to dv by dt, and you have v equal to dx by dt,
Yeah.
right? So there is no function of time here. The only function here is based on the elongation. It is a function of
Yeah.
x. Did you get it?
Yeah.
Because time doesn't matter here. You know the final elongation. We know the initial elongation is 0. So everything we should write it in terms of the elongation, that is x. So what they did is they converted this a into a
Hmm.
function of x. Did you get it?
Yeah. Yeah.
They manipulated the acceleration. So a equal to dv by dt,
DT.
and v equal
And
to
DV.
dx by dt. If
Yeah.
you play around a bit, you get a equal to v dv by dx. Did you get this?
Yeah.
And it's a very important result, guys. Just try to remember this: a equal to v dv by
Yeah.
dx. Don't try to derive it in the exam. So that's all. They have this thing as a function of x, and one more condition is when this thing just leaves the ground, what is the velocity of mass m? It just leaves the ground. So just remember this whenever these kind of questions come, you take the velocity of that mass to be 0. All right. Just
Okay.
remember this. When it just leaves the ground, the velocity of the mass is 0. The normal reaction force is 0. And what else should I tell you? Everything I've given. Okay. Yeah, that's all. So you know all
Yeah.
this stuff.
Yeah.
You have the velocity uh, in terms of as a function of x. So to find v, you just integrate it, right? You can take dx this side and v
Yeah.
dv this side. So if you integrate it, what is the integration of v dv?
V.
V dv is v square by 2, right?
Ah, V square by 2. Sorry. Sorry. Sorry.
And in this case, if you take the dx this side and if you integrate it, uh,
Yeah.
you get something.
Yeah.
So the integration is fine. The important thing is the constants. What is the
Yeah.
const? How do we take the constants?
G is constant. K
No,
and
no,
M.
no, not this constant. I'm talking about sorry, what do you call this? The upper and lower limit
Limit.
of
Yeah.
So the limits, how do you take limits? That's what is important here.
Yeah.
So this one is fine. The elongation is zero, and the
Then
maximum elongation is x naught.
x naught.
Right.
Yeah.
This part is fine. This part they took zero and zero. So yeah, why do you think?
Zero because the initial velocity was zero.
Yeah, initial velocity of this block was zero,
Yeah.
and when it just leaves the ground, I told you just now that
It will be zero.
you take the velocity zero. So
Uh,
that's the key thing you need to understand. A lot of people get stuck up there. They just don't know how to take the conditions, and they don't know. They just forget how to do this manipulation. If you know these two, then I think this question is pretty simple, right?
Yeah.
So if you do the limits here, it'll be zero anyway. Now integrate this. If you integrate this, you get you get this, right?
Yeah.
So if you get this, what? Then what?
Then
Then you get the value of
we can.
x naught, right?
Yeah. We
So
can.
for the value of x naught, uh, then do you and you substitute it from the in the equations which we derived from the beginning. So in the beginning, you remember the equation of capital M, right?
Yeah.
So we said mg sorry, downwards equal to the kx,
Yeah.
right? So if you substitute it in that equation, you get
By
small
two.
times capital M.
Yeah.
So let me just recap everything. Uh, the primary condition which you all need to remember is what happens when this thing just leaves the ground. When it just leaves the ground, uh, you need to
The
cause
normal.
it to be at rest.
Yeah.
It's not moving. So you take the velocity as zero, and
Uh,
all the upward force is equal to the downward force.
the downward.
And second thing which you need to remember is the spring.
Tension won't affect that mass.
I didn't get you what?
You said that the tension of the string won't affect that capital M.
Yeah, it's because the spring is there here, right?
Yeah.
So since the spring is here, only the spring force acts on capital M.
Yeah.
The spring exerts equal forces on both sides. That's one thing to remember. And yeah, since you know the boundary conditions of the elongation of the spring, you can write it in terms of elongation. And just remember this acceleration can be written as v dv
Yeah.
by dx.
dT by dx.
And yeah, this is the only key thing. A lot of people don't know this, and they get stuck up. If you know this, and if you know that the velocity just after releasing it is zero,
Zero.
I think you can solve the question.
Yeah.
So yeah, they generally do not ask these kind of questions in BITSAT. They ask this in JEE very often. So yeah, just be. I mean, it's okay to get prepared for the worst.
Yeah.
So yeah, that was a good question. Did you guys get it? I think a lot of people. Mukesh, okay, Mukesh only. So yeah, and I think this is the last question. This is the last kind of question they ask. A block of mass 5 kg is placed on a rough plane.
Roughly.
The inclination is gradually increased till the block just begins to slide down. The inclination of the plane is 3 in 5, the coefficient of friction. Okay, first of all, do you know what 3 in 5 means?
No.
3 in 5 means it is tan theta.
Okay.
3,
But
yeah, it's tan theta. You got it.
I still didn't get it.
Uh, 3 in 5 is opposite. So it's sine theta. Uh, they generally write the angle in this term. So 3 and 5 is basically 3 is the opposite side of the angle and 5 is the
Okay.
hypotenuse.
Okay, got it.
Yeah, sometimes they give the angle in this notation to try to remember this. So
Yeah.
what is happening is there's a block uh, and the angle is slightly increasing, right?
Yeah.
Yeah, the graduation is increasing, and at one particular graduation at one particular angle, the block starts to slide, and they're asking the uh, coefficient of friction. So, yeah, this is a very straightforward question. If you know the concept of angle of friction, do you know what angle of friction is?
Yeah.
What is it?
Uh,
Okay, angle of friction is basically the minimum inclination at which a block starts to slide. Is angle of friction,
okay.
and
Yeah.
angle of friction is equal to uh, I think it's angle of okay, fine. Oh yeah. So yeah, the minimum angle at which a block starts to slide is called angle of friction, and the value of angle of friction, that is nu, is equal to tan theta. Just remember.
Okay.
So if you want to know how you derive it, there's a derivation. What you do is,
I think I have that derivation in my
yeah,
notes.
if you know
I
the,
just haven't revised it.
yeah, if you put a block here, just mg center downwards, mg cos
Yeah.
theta this way,
Yeah.
and yeah, if you equate mg sin theta to the friction, you get this nu equal to tan theta. That's all.
Yeah.
So
Okay. It's very easy.
very easy, right? So it's just one
Yeah.
equation. But it's better to remember this result, angle of friction,
He mu is equal to tan theta.
tan theta. And there's one more thing you should remember is there's a block and there's a force acting. There's a force pushing the block, right? Uh,
Yeah.
at which angle, if you apply uh, the force will be minimum. They ask that kind of questions. So
Okay.
that's also the same. They ask the minimum force at between the normal and the application of force, such that uh, the force required to push the block is minimum, even that is equal to tan theta,
Okay.
tan theta upon u. So just remember these two things,
Yeah.
and that's all. If you know this, it's just 10 seconds. Did you
Yeah.
get?
It's very easy. Got it.
Yeah, these were the major kind of questions which come in NLM, and I try to solve them with the minimum knowledge possible. See, you didn't use
Yeah.
formulas anywhere, right?
Yeah.
Uh, just logic, and then applying friction and writing equations. So,
Yes.
yeah, this is a very simple chapter, and after the session, I want you guys to be able to solve any single question which comes in BITSAT.
Yeah.
So generally they ask like two questions uh, from this side, from NLM and friction. So yeah, I want you guys to get 6 marks for sure.
Done.
Yeah, so that was it, guys. If you wanna ask me anything, just ask me. Uh, okay, you wanna talk something? Bhumika, you wanna say something?
Thank you for the session. I thought I know NLM, but yeah, I made many silly mistakes.
Yeah, let's try to avoid them, especially in BITSAT.
Yeah.
Sorry
Yeah.
guys, my graphic tablet is not working.
Ah,
It's not.
you told it.
Yeah, usually last year we used to solve questions using that. Hey, thanks, Mukesh. And we had a lot of fun last year also. A lot of them are my juniors here at BITS.
Oh, so you are not a fresher.
No, I'm not. I'm a second year.
Second year. Nice. I have a friend in Vetskova who is in
Who is it?
second year. It's Shlok Gupta.
Shlok. Okay. Upadhyay.
You know him? You know him?
I know Shlok.
Oh, nice.
Yeah, yeah. So, yeah, that was it, guys. Got to revise the main concepts. Yeah, just I told you, no, I showed you the formulas, right? The two
Yeah.
slides. That's all you need to remember. And rest all it's just logic. So yeah,
Thank you.
have fun,
It
guys.
was
We'll meet.
very fun.
Yep. We meet. I think next Saturday. I guess.
Yeah.
All right. GG. Bye.
Bye. Thank you.
See you, Mukesh. Hari.